So what I'm going to do is I'm going to connect you about the core switch configuration. So on the core switch, we have built the layer 3 OSPF and the VPN 20, like I was explaining. This is a VPN 20, this is a VPN 10, right? And what we have is that so far we have built a control connection. So one control connection is made like this to each device, right? Right? I mean each controller, and further we have made another control connection which is over the MPLS, taking all the way path like this and being netted on this interface, going to reach this guy, and from here it is having a one control connection to this, other control connection to this, and third control connection. So we have a control connection from each VH to each controller. Okay. Now, what does it mean by that? Why we are having this as an additional control connection? Let's say assume if this ISP or this link go down. Okay. I'm sorry. So, so if this ISP go down, what will happen? That our traffic, I mean, our vManage or vSmart will still be able to talk to the VH over the other transport, which is the MPLS, right? So that's how it will, continue talking to the controllers, or would be able to make any change. Similarly, if the MPLS lost, the other controller, I mean, other link will work and will be able to make the control connection. And all these control connections are the DTLS, right? So what are those? DTLS. Now, so this is about the getting the control plane information, management configuration from the vManage, getting the orchestrator. Now, how our traffic is going to be forwarded is that, let me do this. So to forward our traffic, what it is doing is that, let's say DC1 core is sending a one route to this guy. This will send this route to the vSmart. So what does it mean by that? We are establishing the OMP between VH to the vSmart. Over the DTLS tunnel, which is the control connection, we are building up the OMP between the VH to the vSmart. So what does it mean by that? Each VH is having a control connection. I mean, the OMP peering to the vSmart with with both of those transport, right? So other one is the like this, right? So that's how your vSmart is getting the routing information from the VH and then further sending that routing information to the other VSs, right? What does it mean by that? Now, who become a boss is the vSmart, right? Because everyone is going to talk to the vSmart, and then vSmart is relaying that information to other VSs, following that OMP neighborship or OMP peer, which is actually being built on the control connection, right? Over the DTLS tunnel, right? So now, what does it mean by that? Every time when I see that the route is being learned from vSmart, I don't have any neighborship between the VH to VH. All my OMP neighborship are VH to the vSmart, right? Now, depending on if you have a more than one vSmart, depending on the lower system IP address, the vSmart will be chosen to select as a route, install the route. But if you have more than one vSmart, both of the vSmart will send a copy of the route to the VH, and one of them will become as a best path, and based on the system IP address. So the one who is having a lower system IP address would be preferred over the VH, and if that is lost, in the other vSmart route get into the routing table. Right now, how my traffic is being forwarded actually. So since I'm getting the vSmart, doesn't mean that my next hop is a vSmart. If that would be the case, then every traffic will go to the vSmart and will route back to the VS. So that will be, will become a limitation of this solution. So how the Cisco SD-WAN did is that they make the, this vSmart is sending out the next hop information to the VH, okay? And what next hop information? From where it learned actually that route. So it says that if you want to reach to the DC1 VH subnet, where you need to reach is the next hop IP address of the DC1 VH, right? Now, what next hop IP address itself is, because this is a public cloud, right? So there has to be a sort of private and public mapping to find out that who is and where. That's where it used the TLOC IP address. So we call it a TLOC transport locator IP address. Okay, so your TLOC IP address is the next hop. Okay, so in this case, our TLOC IP address is this, but this TLOC IP address, this TLOC next hop is being built in a combination of the more than 3 tuples. So major are the 3 tuples is, for an example, the system IP address, right? The IP address of the interface, public IP pool or private IP pool, and then the color, on which color the traffic should be going. So here, one of the tuple, part of the tuple is the system IP address, WAN IP address, and then the color of that WAN interface, right? That's where it used that information to reach that, right? So now it got the private and public mapping, right? So for an example, if I'm getting let's say I'm advertising 172, I'll see something like this. Let me delete it for a moment. So let's say if I'm advertising, that doesn't work actually. So if I'm advertising 172.100.10.x, then this route will go to this and will go like this, and then will go like this, and will be returned back now to this VS. Now, what would be my next hop IP address? Is the 10.10.98.21.4, right? So this .4 is my IP address as a next hop. Now, how to reach this IP address? That's where it used the TLOC and other route table to reach this 10.98.21.4. That's what we call it, a TLOC IP address, right? Or how to reach to that next hop IP address, right? So it got this IP address, how to reach this IP address. It got this interface IP address, it got the color, it got the encapsulation, and then and it is dynamically building up the IPsec tunnel between this VH to this VH and running a BFT over it, right? So that's where I'll explain the OMP part of it. Let me go back, and so here, I hope you are able to see my screen in regards of the OMP. Okay, so OMP is the management protocol, okay, which is a OMP routing protocol, which is similar to the BGP, manage the SD-WAN overlay network. So who does take care of the overlay network? Is the OMP. So the protocol, runs between the vSmart controller and the VHS router, where the control plane information is exchanged. So who is exchanging the control plane routing and all those stuff is the vSmart. So we had sent to the vSmart relay that information to the rest of the VSs which are paired with it, right? Such as a route prefix, next hop route, crypto key, and the policy information is exchanged over the secure DTLS tunnel and the TLS connection, which we talked about, right? So the vSmart over the DTLS and TLS tunnel is sending that information utilizing the OMP protocol, right? What information? The the prefix which it learned from the other location, the next hop of that prefix, crypto key to build the IPsec with that, and the other policy information, which we will talk about what are the different type of the policies we have, right? So vSmart get the power to sit into the mid and make sure that it can pass on that communication. So vSmart controller act a lot like a route reflector. Okay, so what does it mean by it act as a route reflector? Is that it, same in a BGP, what we have is that it receive the route from the client and non-client and send that route to the other client which are connected. So similar way, any route is being advertised to the vSmart, and then vSmart relay this to the VSS. That's the reason we call it act more act like a route reflector, right? So process apply any policy to them and then advertise the routes to other VS in the overlay network. So if you understand this, basically this got a power, right? vSmart got a power where it can apply any policy. You want to tweak the metric, you want to tweak anything from the vSmart. So what it will happen is that the route will come to the vSmart. vSmart, based on your policy, will modify the setting within that route and then can further advertise the same route to the other overlay network. Right? Any questions so far on basic understanding of the OMP? Now, how OMP does all that stuff? So OMP basically advertises three type of the route. Okay, so it advertises three type of the routing table to each VH. Right. Number one, OMP routes are the prefixes that are learned from the local side of the VS router. OMP routes advertise attributes such as a TLOC information, which is similar to the BGP next hop IP address for the route. And OMP route is only installed when the forwarding table of the TLOC to which it point is active. So what does it mean by that? If the next hop is same like in a BGP, if the next hop is not reachable, it will not install that route into the OMP, into the routing table. So OMP still can advertise the route if there is a no reachability by the VH to the other VS to VS TLOC IP address. It cannot, it will not allow to form the, it will not allow to install the route into the routing table. So there are three tables. One is the OMP route table. Second one is the TLOC routes table, right? So one thing you got to know that, okay, this is the destination I want to reach, and this is my next hop I want to reach. But that next hop IP address, there should be a way to reach that next hop IP address, right? So in this case, what it says is that it advertises separate routing table to reach out to it. Now, that's what we call it a TLOC routes. Are the logical tunnel termination point on the VEdge router that connect into the transport network. Okay, that connect into the transport network. A TLOC route is uniquely identified and represented by the three tuples, consist of the system IP address, link color, and the encapsulation, right? So what does it mean by that? How to reach to the TLOC is that this is the three information are being encoded into the TLOC route table. So let's say I say that, okay, to reach to the 172.100.10.x, your next hop address is the 1098.21.4, right? So for an example, if you go back in the, so if you say that, okay, I want to this to route, it got the next hop IP address this, but how to reach to that next hop IP address, that's where the TLOC route table will tell. And now once you got to know everything about the next hop reachability, about your target destination, it can simply reach it, right? So that's how the routing table does work in this case. So OMP got the one is the route prefix, and other one is the TLOC route, which does have the system IP address, link color, and the encapsulation. It can be a GRE or IPsec. Next type of the route what it advertises is the service route. Okay, so what is a service route? It is a different type of the route which you have not seen in the previous services. What it do, previous solutions is the service route tell you that if you want to insert a specific service into the network path. So what does it mean by that? Let's say for an example, you have a huge big network infrastructure, and you want your network infrastructure to be protected by the firewall, right? Now it's not possible to, it's not a good solution to deploy the firewall every site and manage that firewall everywhere, right? It is a tedious task and all those stuff. So what if you want to use the regional firewall architecture for all the traffic, any of the specific traffic which you want to insert, that should be go by the firewall and should be scanned once by the firewall. So that's where this type of the service type of the route is being used to insert the specific service. So what will happen? The next hop will be changed. So let's say for an example, if you want to reach to the let's say, and if I'll take the other topology, let's say if you have this firewall, okay, this firewall, you want to say that any traffic being originated from this site to the XYZ destination on the data center or any other remote site should be first hitting on the firewall and then going to the destination, whichever destination you want to go, let's say like this, something like this, or any other remote site. That's where what it will do, instead of advertising a next hop of this VH, because it can directly reach like this, right? But instead of advertising that VH next hop, it will insert the services in a firewall. So the traffic will originated from this side will see as in a firewall as a next hop IP address. So once it reaches to the firewall will do the scan and will return back the traffic towards to the destination site. And that's how the traffic will go. Right? So the service type of the route which we use to insert the specific service in the solution. Right? So we have the following diagram. So the DTLS, TLS established between the VS router and the vSmart controller, over which OMP runs. The TLOC are indicated by the colored circle. So what are the TLOC? Is 1.1.1 and 2.2.2, which are a different color, right? And to reach this guy, I mean, this is being further being advertised from the OMP, to the one VS to the other VS. So that's how it will reach to the, the location. So IPsec tunnels are established between the TLOC over the each transport. Once the IPsec tunnels are established, the BFT will run on top of those IPsec tunnel. And why we run the BFT is to measure if there is a link issue, link is totally down, or the packet loss or latency. That's what BFT does actually measure and provide you the fast failover, or when there is a WAN outage, right? So every tunnel by default run the BFT. Now, to connect back you that, how does it look like in actual, I'll connect you one of the device. So let's say DC1 core 1. Okay. So IP INT brief. So we have created, set of this thing. We have created the few loopback interfaces, which are actually a part of, my VPN 10. And then there's a one VLAN which I have created into the VPN 10 is the VLAN 10. So if I'll do so run VLAN 10, so run interface VLAN 10, it says it is a a production user having the 172.100.10.254, right? Now if I want to see this 172.100.10.254 and looking on the VR1, that's where I want to see the admin. So IP route VPN 10 172.100.10.0. Okay. So if I let me do that. So in this description. Okay. So control connection. Let me quickly verify the control connections and all this. So I will 172.100.10.0/24. So IP. Okay, I'm sorry, I should say /24. So it says that to reach to the 172.10.0/24, you have two paths. I mean, one to the TLOC IP address this, right? And I think I still have some issue which I need to figure out. So 172, can be reached to the 1098.21.4 and 1098.21.5, right? So what does it mean by that? These are my next hop IP address, right? Now, how to reach these next hop IP address? That's where it built the another table, which we call it so OMP route TLOC. So I will TLOC out. TLOC. And I'll put 1098.21.4 table. Check what I missed. IP 1098.21.4. And then what we have next is the table. Let me see. So what it is saying, to reach to the 1098.21.4, you have two possible color. One is the MPLS, which is also CIR, chosen install result. And how to reach to this, 1098.21.4 is the, this is being learned from the Nexthope vSmart, right? And status is chosen, install, and result, right? And how to reach this is the public IP address to reach this is this guy, and private IP address of that is this guy. So that's how it can reach to that following the underlay, which means to say it does have the routing table for 1.1.250 and can reach out that, right? Similarly, 1098.20.1.20.21.4 is reachable over the biz internet, right? Of course, being learned from the same vSmart. And this time the public IP address 1.1.12 as well as a private IP address of 1.1.12. So that means to say there is a no netting. But in the other case, the private and public are different. That means the netting is in place, right? So what it have is the another table, we call it a TLOC table. So instead of looking for one specific IP address, you can look for entire of that. So let me do this. Let me see. So we can see that we have, TLOC for 1098.21.4, right? We have TLOC for 1098.21.5, 6, 7, right? 8, and 9, and then 10, right? So you can see which are down. You can see the 8 is down, right? Now, why 8 is down? Because if you will go back on the topology, 8, I'm sorry, give me 1 second. 8 is being assigned to the same location site ID. So you are looking on this guy and you are on, for this targeted, it is the same site ID. So you don't need the connectivity to go like this and all that stuff. It is saying that since you are on the same site, you are not allowed to build the tunnel within the same site, right? So that's the reason you are seeing that lockdown, right? Now, that's how you can see the, routing tape, how to reach to the Nexthope IP address. You can see the OMP route VPN 10. Let me put a table to see more. So if you see 172.10. This is reachable, over the, this thing 9, right? And saying that it can reach by the biz and MPLS. Also, you can see the 20.12 is reachable over the 9, over the biz and MPLS, and then you can see 100 is being saying that 100 is having the total 4 path, right? These 4 path. Out of these 4 paths, only 2 paths are being considered to be chosen and resolved. So it says that biz internet for this one, MPLS for this one, and that is probably because of IPsec preference. I need to check that why IPsec preference is, maybe, while I was filling up, maybe I made some, I have to fill up same value, but I missed somewhere. So that's the reason you can see that, in total you have 4 paths, but other 2 are in the downstream. Are not installed into the routing table. So right now it can load balance the traffic between the 4 and 5, one with the biz internet, other one over the MPLS. And that's where you see the encapsulation IPsec, right? So that's where you see the, the entire routing table of the OMP. So if you notice one thing carefully, is the label is being assigned for this each prefix, right? 103, 103, 103, right? So what does it mean by that? That it will, and that's about the VPN 10, right? But if you see for the VPN 20, the label is 104. So that's where the label is indicating that you are your virtual path is separate, or you have a VPN segmentation. That's how it is doing a VPN segmentation. On the other side, you have for a VPN 10, you have this, right? 103. So the label is being used to segregate the do the VPN segmentation and all those stuff.